Hello grade 12s, welcome to my channel. Let us have a look at this question from way back, March 2018, just as a way of practicing, keeping it going. This week from Monday, we're going to resume our classes. Please guys, attend in numbers and make sure you work with those problems we will be discussing, and make sure guys you are prepared for each class. I will communicate before each class the materials that we're going to be using during the classes, and of course questions are also welcome once we have covered what was planned for the day. So I'll see you again on Monday, but for now just watch this and get yourself back into the groove. So we're going to be handling this question 4. So we are told here that in the diagram PKT is a common tangent to both circles at point K. So first of all, that point K is given in a way that is suggestive. We need to think about finding those coordinates. But we also know that a tangent is also perpendicular to a line drawn from the center, which is the radius, or the diameter for that matter. So that's the situation at point K. Okay, great. So that's what we can say so far. Now the centers of both circles lie on the line y equals half x. So it means these are collinear, right, on that line. Okay. So the equation of the circle centered at O, the origin, is x squared plus y squared equals 180. Not a problem. So this will help us to work out the radius, right? KO. Right, no problem. So the radius of the circle, so which one, is 3 times that of the circle centered at M. So this means that the circle centered at the origin, okay? So this statement is suggesting that if we say MK, for example, the radius of the small circle is R, KO, which is the radius of the bigger circle, is going to be 3 times that. So that's what we get from that statement, okay? So now that we have read and seen where all the pieces of that information fit, what can we do about it? Usually for any student, we often would want to look at point K as well as point M, because these are important points. A center is very important, and a point on the circumference that is not given is somewhat important. So these are the 2 important areas. P and T don't really matter, but we should consider how will we find the equation of that tangent. So what can we do? We will see that, okay, point K lies on the circle, so we can substitute into that equation, and also lies on this line. We can substitute into this equation and then solve simultaneously, and therefore we will find the coordinates of K. But it won't just give us the x value at K as well as the y value at K. We'll also get the x and the y values at this point. But now we just have to discard the values that would fit the other point. But those that would fit a point in the 3rd quadrant will qualify. Right, so that's what we can do about finding the coordinates of K. And once we have the coordinates of K, we can actually find the equation of the tangent, PKT, seeing that the gradient of that line is already given, and that line being perpendicular to PKT, it's already telling us that the gradient of PKT will be the negative reciprocal of that gradient, which is going to be -2. And using point K, we can find the equation of PKT. Now what about M? So point M at this stage is X is to Y. What can we do to find the coordinates of M? Well, we can look at these two circles. We will see that these two circles actually, they touch at one point externally. So it means the distance between their radii is equal to the sum of the actual radii. We can use that to derive one equation in terms of the x coordinate at M. 2, we can then add up those two radii using this piece right here as the actual value. So we can derive an equation there with both x and y as unknowns. But we see that point M still lies on this line. So we can substitute those x and y right in there. And guess what? Solving simultaneously again will give us the coordinates of M. Yes, it won't give us that point only, but it will also give us a situation where this point M is somewhere over here. So we need to avoid values that would fit that kind of a scenario. Okay, so that's the idea behind finding those points. So it looks like we can work out everything. So if we see ourselves in this position, we don't really need to skim and scan the questions per se. We can just work through each nicely. But in the exam, you would want to look at that and so to see if you've got a game plan for each of those questions. In fact, let's just demonstrate that. It says write down the length OK in set form. We've got it because this piece right here is going to give us that. So that's in the bag. We need to show the coordinates of point K are -12 and -6. Again, we've got a plan. Simultaneous equations will take us through. So we've got that question in the bag as well. Of course, if we don't make any mistakes. Now again, 4.3 says determine. Again, here we are at liberty to do it whichever way we see fit. So the equation of the common tangent, again, we've worked out a plan for that. It's in the bag. The coordinates of M in the bag. The equation of the smaller circle in this form. So once we've got the point M, which is its center, we've got a point K at the circumference, and it's already confirmed what it should look like. So that 2 marks is in the bag. For which values of R will another circle, okay, now this one is going to be quite naughty, intersect the circle centered at M at 2 distinct points? So this is another circle. So this is one of those questions that stretch our imagination. Okay, we can think about it as we go into it. But again, if they are to touch at 2 distinct points, so we know that we need to have a situation like this. Right? So that's the idea. So we just need to work out those issues nicely. And then we are told that another circle, okay, it's given in the expanded form, is drawn. We need to prove by calculation. See here, we are dictated to as to how we're going to solve this problem. No other means is allowed. We need to show a calculation. That this circle does not cut the circle with center M. Again, can you see the coordinates of M are given here? So it means we now need to find M to be -16 is to -8. So can you see certain pieces of information are all over the show, but we know that, okay, we've got these 2 questions perhaps to deal with at a later stage, because these are trying to look like higher grade questions, I would suppose. The others are fairly simple because, I mean, it's standard approach that can take us across here. Okay, so let's see. Is there anything more we can do? Not really. Let's just answer some questions. Right, so we were told to write down the length of OK in surd form. So this is easy. 4.1, we know that OK is the radius of the bigger circle. So this is going to be the square root of 180 units. Please do not forget the unit of measurement for a distance. Easy. Question said write down, so no need to show any reasoning behind it. Now we need to show that K is this point. So we've got that plan. So well, we're going to say fine. We're given y is equal to a half of x, okay? Now through point K with coordinates A and B, it is such that B is going to be equal to a half of A. But now we don't really like fractions. We can cross multiply the two. We can just solve for A. All right. So we can make this equation 1. We can say likewise, we've got x squared plus y squared equals 180. Point K with coordinates A and B will tell us that we've got a squared plus b squared equals 180. And this gives us equation 2. All right. So please, guys, go through the process. Of course, a student who knows this, you can just easily take the equation of the circle and the equation of that straight line, solve simultaneously, pick the x coordinate that fits point K, as well as the y coordinate that fits point K. But at this stage, we just want to work through these problems, systematically displaying every step actually that is applied. Now we will just say put 1 into 2. So what do we see? A is 2b plus b squared equals 180. So this implies that 4b squared plus b squared equals 180. So this gives us 5b squared equals 180. So it means b squared is 180 divided by 5 is 36. Right. So taking the square root on either side, what are we going to get? So b is going to be plus minus 6. Therefore b is 6. Right. No, minus 6. Okay. Because b is in the third quadrant. So the y value is negative. So this also implies that our a is going to be 2 into minus 6 when we substitute back into our equation, which is basically minus 12. Therefore, that point K is basically minus 12 is to minus 6. Nice and easy. So simultaneous equations, guys, are not just taught, to waste your time. You will definitely need to apply them. So of course, guys, deriving that equation is quite key. And that, right? And the technique of solving simultaneously, and of course writing the point back. The rest is just arithmetic / algebra. I hope we are clear on this one. So we have the coordinates of K. Great. So we have now 4.3. Maybe let's just start 4.3 on a new page. So 4.3.1, we need to determine the equation of the common tangent, okay? We know that the gradient of p kt multiplied by the gradient of OK or KO should be minus 1. We know that the tangent is always perpendicular to radius. So this implies that the gradient of pkt into a half Why do I know it's a half? Because the gradient of the radius is given is equal to minus 1. Therefore, the gradient of pkt is equal to minus 2. We can say then pkt, right, is y equals minus 2x plus c. Through point K, which we found as minus 12 is to minus 6, we know that minus 6 is equal to minus 2 into minus 12 plus c, which implies that c is going to be equal to, now this is 24. When we transpose it, it becomes minus 24. This gives us minus 30. All right. Therefore, y is going to be minus 2x minus 30. Nice. So we can accept the gradient as well as the y-intercept looking at that line. So what is important here is this dude, the substitution, and the delivery, okay? So you can see how everything is going. Ideally, this is a 4-mark question because this deserves a mark, especially this part. And also this deserves a mark. So a 5 marks can be constructed from just that question. Okay, so we have 4.3.2. Now 4.3.2 says we need to show the coordinates of M. In fact, we need to determine the coordinates of M. We got this secret from skimming and scanning the questions. So sometimes doing that is not only beneficial when you don't have enough pieces of information for what you see on the diagram and perhaps grading those as important. But sometimes doing so, as you can see, can uncover some answers for us so that as we work through the problem, we can actually see what is going on. So we need to think about this. Now, folks, let's see. How about we take this point back into the x-axis? Right? Right. If we do that, let's copy this and paste it so that we have some parallel lines. Make it bigger. And then take it here as well. So when we take those points back into the x-axis, of course, these are lines we are drawing ourselves. They were not given. We will know that these lines are themselves perpendicular to the x-axis, right? Because the y-coordinate at any point is a vertical distance from the x-axis, isn't it? Yes. So this already tells us that these two lines must be parallel. Okay? Now, look at what we have as a result. So we've got that triangle with one line drawn parallel to the other side of the triangle. And we can see the ratio in which this line divides the one side. And so by the same ratio, it will divide the other side, So we can think of it that way. Ratios and proportion. But now we will have to name those points on the x-axis, that point and that point. So T, we can say this is U and say this is V. Okay, so sometimes we may name things. So guys, we've got two options here to deal with this. We're using simultaneous equations as we saw, or we can use ratios and proportion at the same time. I suppose simultaneous equations are going to be the center of it all. Okay, so it looks like this. So now let's have a look. How do we deal with this? Let's just use our ratios and proportion here. We can say let V and U be points on the x-axis such that OV is equal to the x-coordinate at K and OU is equal to the x-coordinate at M. Okay, so always whenever letters were not given and you are putting them, please introduce them. Although there is a sketch given where you can annotate and the examiners are going to see, because remember in each exam there's always that page which is given. I don't know, it used to be the case with us. We used to be given a diagram sheet with all the diagrams in paper 2. Because if there's any annotation the student makes, because on the answer sheet we may find ourselves seeing a V and a U that we don't know where it came from. So those diagrams are provided for these reasons, to protect a student from trouble. But at this point, I want you guys to be in a position to be flexible and creative. Be able to introduce things before you use them, so that even if the diagram is not there, just these statements are enough for a mathematician to follow your thought process. Okay, please remember this. It's very important. Now, if this is the case, it really puts our diagram right there. We can say now in triangle OUM. Right. That's what we want to use. Now here we can just jump in, but we need to provide a reason if we're going to use any proportions. So folks, we understand that OV divided by, now remember I'm going to use this one like that over that, because I'm interested in OU. And the same should apply when I take this over that, because I'm interested in that OU, because OU gives me the x-coordinate at M, and that's what I want. So I'm going to say OV over OU should be equal to OK over OM. Now this is basically the prop theorem. We can state that VK is essentially parallel to UM. Okay, of course, construction. We have done that. And any construction done must be in dashed lines or dotted lines, so that it's clear that it's not really there, but we are doing it because it's going to help us. Nice. So what we're going to do now is, let's see, we substitute. So OV is basically 12 units. So this time we substitute 12 as positive. We don't really care about the sign. Okay. But you can put minus 12. It's not a big deal. OU is what we want. Is equal to, okay, this is 3R divided by OM is going to be 3 plus 1, which is 4R. Now what we know is that this friend takes care of that friend. And we can easily just cross multiply here so that we can get our act together. So at this point, I'm just going to run for the conclusion. Therefore, OU, perhaps we can say this implies that OU, when we isolate, is going to be 4 times 12, which is 48, divided by 3, that's 16. Now, if this is the case, it concludes that the x-coordinate at M is minus 16. Remember, it's on the negative x-axis. So we have one up our sleeve. Nice and easy. Okay, so we just had to be creative and to see things for what they are. Can you see? Those constructions looked a bit illegal if you think about it, but they're actually legal, because if we understand how points are constructed on that Cartesian plane, every y value of any point on the x-axis, on the Cartesian plane, is nothing but a vertical distance from the x-axis, and every x-coordinate on the Cartesian plane is actually a vertical distance from the y-axis. Just remember that. All right, so now we can say also we know that y is a half of x, because we know that the x-coordinate of M lies on that line. So if this is the case, we understand that with point M with minus 16 is to y will be such that y is equal to a half of minus 16. Therefore, y is maybe let's say y at M is going to be minus 8. We can say therefore M is the point minus 16 is to minus 8. Done. Of course, we skimmed and scanned. We found out it is the case, even though it was not necessarily volunteered. Be very careful, though, to take information from down below and put it back up. You might run into problems. It has to really be the same question, the same conditions. Because if anything has changed, then you may run into some serious issues. Do not be very careless about this. Okay, guys, so this is it. Can you see it's not so difficult, not so bad after all. Now, let's have a look. This statement and reason is quite key, guys, I believe. And of course, substitutions, we can give them. And finding the x-coordinate, very important. Substitutions again, and finding the y-coordinate. So let's see, 1, 2, 3, 4, 5. Well, we can say 2 marks. Statement and reason would be important, provided we have some construction statement, because none of this existed until we did some construction. This is more like a proof in Euclidean geometry. Yeah, even a mark could be given. Perhaps rather than giving 2 marks here, I would give a mark for that, because this is setting up. Maybe let's be fair, not compound marks to 2 things. Of course, I'm not saying constructions are marked in analytical geometry per se, but I think this is a skillful way of looking at things, you know. And for me, it should be rewarded if you can communicate it. But let's say you are poor at communicating, but you just decided to draw those points on the sketch given and you started working through it. You will definitely get 2 marks for this one, okay? Not a big deal. But for me, I believe in creativity. Remember, guys, we teach you standards that you have to keep up with at the beginning. But once you get the hang of this, the concept, please express yourself with what you have learned. Do not lock yourself into that box. All right. Okay. So that's nice, guys. We've done it. And I feel, what about the simultaneous equation technique? Will it be necessary? Let's try. But I'm going to make it as rough as possible. I'm not going to go about it the way that I would perhaps present this. So I'm going to go about it rough. So we know, guys, that OM squared is going to be essentially equal to basically OK plus MK. Now this would be squared, isn't it? That was given. But now OM squared is basically going to be, say, the x at M minus the x at the origin, which is 0, all squared, plus, we know that this is going to be the y at M minus that at the origin, which is 0, all squared, equals OK. We know that this is the square root of 180. Plus, now MK is that divided by 3. Right? Yani, siyanikhalela. Let's reduce this a bit. It refuses to do the things that I want. All right, so I'm running out of space, guys, so that's why I'm doing what I'm doing. And then we square that. No. I don't know why I put these brackets. I shouldn't. They are not necessary. This one is just the square root of 180 divided by 3, right? And then we square it. So let's see, what do we have here? We've got x squared plus y squared equals, remember that's x and y, 180 plus that. I'm trying to think now. I would rather we sort this out and say, okay, let's just put it on the calculator. It's really not a big deal. So what we have here is square root of 180. Wanted to do it algebraically or arithmetically, whatever you call it, but there's no need for me to sweat. Remember, in the exam, guys, you don't need to struggle. Let's just add those two up. So we get 8 root 5. Okay? 8 root 5. And then we square that. So that's going to be 64 times 5. And 64 times 5 is 320. Okay? Now this is equation 1. And of course, we have y equals a half of x. That makes it, or gives us the equation 2. You get it? Now, all we simply do, we just substitute one into the other. This is meant to be, okay, maybe let's say this is 1, this is 2, so we're going to put 2 into 1. What are we going to have? So we've got x squared plus a half of x all squared equals 320. So this implies that x squared plus this is going to be just x squared over 4 equals 320. And then we multiply, we don't need to. Let's just add this up. So this is going to be times 4 plus 1. This is 5x squared over 4 equals 320. And then we have ourselves 5x squared equals 4 times 320. That should be 320 times 4. My brain is locked. It's 12,000. Not 12, but 1,280. And then we divide by 5. So we will have x squared equals, that divided by 5 gives us 256. And we know this is 16 squared. So this implies that x is going to be plus or minus 16. Therefore, x is minus 16. Okay? And therefore, y is going to be half of minus 16, which is minus 8. Okay? So that's how one could use simultaneous equations to sort out issues there. Okay? Just wanted to show it in case that's the only way you thought about it, or at least to give you a nice practice. Okay, let's move, guys. 4.3.3. Now, we need to find the equation of the smaller circle. Very easy. So, at this point, a thing that says determine, we can just write the answer. So, this is going to be x minus minus. The x coordinate at m is going to be 16 all squared plus y minus minus 8 k all squared equals, now remember this part here is basically square root of 180 divided by 3 all squared. Now let's sort that out. See what is that. Root 180 divided by 3. K is that. And then we square that, it gives us 20. So all we can do, we can just get rid of this business and just write 20 here. We can score marks here. This way, that way, and that way. Okay? It's very simple. Or just say 3 marks for the answer. This one is easy to deal with, but I think this is a bit risky though. It's a bit risky. But the question that says determine, 3 marks here. Actually 2, yeah, this is good. This is good. 2 marks left hand side, 1 mark, right hand side, 1 mark. So that's good, yeah. Here you are forgiven if you don't show, but 3 marks, be very careful. Show us the workings rather. Right, so that's easy, no problem. So let's see 4.4. Saying for which values of r will another circle with equation, meaning a circle centered at the origin, intersect the circle centered at M at two distinct points. Obviously, we understand that this is the scenario that we are painting. We are painting a scenario like this. We want that circle to be bigger than this. Right. So we will take it out, expand it a bit, so that it gives us what we want. Okay, that's not nice. Yeah, it's much better. So can you see, it cannot be equal to this circle because its radius is going to make it just touch at one point. But when it is bigger than that circle, we start to see stuff. We start to see stuff, but I wanted to put it nicely. It's just that it's betraying me. Bastard. Okay, so this is the stuff that we want to portray, guys. Can you see this circle of ours? When it is bigger than this first radius, this first circle centered at the origin, do we see that it has actually 2 points of intersection with the circle centered at M? Right. So this suggests that R must be greater than OK, which is the square root of 180. But there's a bit of a catch to this. This very circle of ours, this very circle of ours okay, let me make it a bit outrageous, must avoid going, okay, maybe a bit more. It must avoid doing stuff. This is the limit. Right. But now I did not center this at the origin. It should have a center there. Okay, that looks a bit okay-ish. Yeah. Now, we need to avoid a situation when this it has to avoid a situation like that. Okay, guys, there's a lot of work here being done. So this is the limit. This is how big it should be. The limit, by the way, because this one touches this circle internally at that point, and we should avoid touching that externally at one point. But anything in between would fit what we want, because this fits the description, meaning the radius of this circle must be greater than OK, but it surely must be less than O, whatever that point is. So this particular length, what can I say? Yeah, that distance must be avoided. Okay, so basically that's the idea. So we can say here R must be less than that big length. Remember, this is OK, which is root 180, and this is basically root 180 divided by 2, which is going to be, remember, that's 6 root 5, so that becomes 2 root 5, okay? So this is 2 root 5, but again, we can just go about it and say this one must be greater than root of 180, but surely less than the sum of the root of 180 plus 2 times the root of 180 divided by 3, isn't it? Because remember, that would be the diameter of the smaller circle to get to that line. Okay, so that's the case. So we can say, therefore, our r must be less than, well, let's see, is it necessary for me to change anything? Let's see, square root of 180 plus 2 into the square root of 180 divided by 3. What do I get? It's 10 root 5. So I'm getting 10 root 5. So this is 6 root 5. Okay, that's it. If that's the case, we are actually fitting the description of this circle, of course, knowing the limits. Okay, so how many marks was this? 3 marks. Okay, so I would say this and that gives us a mark, but this whole calculation up there is good enough, I guess. I mean, there's a lot of things we had to do there. There's a lot of things we had to do. So either way, 3 marks can be scored. Whoa, the symbol must be there. Is it a symbol or a sign? Yeah, whatever it is. Okay, guys. So I'm sure you understand what we did there. If you did not, please do shout your question in the comment box below. Do not sit back and pretend you are fine. The reason I'm trying to take you guys systematically here is to make sure that you can see everything, and also to give you an idea on how to annotate diagrams. Remember, in the exam, you must have your instrument box. You can do these circles using your your compass. So there's in pencil. So all of these things, guys, you can do in the exam. And as you can see, despite all my annotations, you can see everything. You know, the colored pencils can be used to shade that triangle. You know, just nice lines so that everything, as busy as it is, someone will follow. You can follow, I can follow, anybody can. So that's the idea. Yo, guys, this thing is gonna go off. I don't know why I set while it's screaming for power. Let's give it power before it goes down on us. So let's do, guys. Let's finish this nicely. So it says, okay, we have enough space here. So 4.5 says another circle, x squared plus y squared plus 32 is drawn. Prove by calculation that this circle does not cut the circle with center M. Okay, how will we prove it? We need to show this in standard form so that we can see how it relates. In fact, what are the parameters? What we need is the center and its radius, because once we know those, we can then compare it to the other one. So we can say the circle, whatever it is such that we've got, okay, it's set by calculation, so we need to show everything here. So this is x squared, we bring in the x term plus 32, right? And then plus y squared plus 16y. This is equal to minus 240. We're just going to complete the square here, which implies that we've got x, so this is meant to be x. So we've got x squared plus 32x plus, we're going to half 32. This is 16. Or perhaps we write it as 32 over 2 plus y squared plus 16y plus, we will add 16 divided by 2 equals minus 240 plus we will add this 32 over 2 all squared plus 16 over 2 all squared. By the way, these are supposed to be squared. Nice. Okay, remember we follow instructions, guys. So we take what is under the square, original sign, then we take this bracket, what is under the square, and then we square the whole thing. Same here, we take what is under the square, sign before them, and we take the outcomes of that bracket, which is just going to be 8 all squared equals. Now we're going to sort that out. So we've got minus 240 plus essentially 16 squared plus essentially 8 squared. So this gives us 80. Right. So can you see that's the equation? So we can say therefore the circle has center minus 16 is to minus 8, right? And radius, which is going to be the square root of 80. Right. Now, while circle center M has center minus 16 is to minus 8 as well, and radius equal to the square root of 20. Right, because we found that equation above. Now, what are we saying here? We can say, therefore, they have the same center, different radii. 1/8 is greater than 20. So basically, this circle is greater than that circle, but they share the same center. If we can just draw it nicely. All right, so just draw it nicely. So this is the situation right there. Maybe let's make it a bit smaller so that we don't have a situation. Okay, we can if we want, but yeah, this is more like it. So these are concentric circles with different radii, so these ones will never meet. So we can say, therefore, the two circles are concentric with different radii, and so will never touch. It will never touch each other, or will never intersect. And so, okay, these circles are concentric, meaning they have the same center with different radii, and so will never intersect. Okay. So see, guys, we've proven this by calculation, but the calculation was completing the square. But remember, we cannot just jump into the answer. We have to show how we complete the square. So this is another way the examiners are just forcing us down the path of showing how we complete the square systematically. So how do we score these 5 marks? Well, I don't know, guys, but yeah, I would give a mark for this, and pointing out the center of this circle and its radius, then comparing it with the other one, very important. And to say these two are concentric, I think that's a mark. I don't know how ridiculous that is. Perhaps the conclusion, we can say 2 marks or 1 mark. Maybe let's say 1 mark, the conclusion as a whole, rather than just the concentricity of the 2 circles. But perhaps the technique here is key, I guess, because we were supposed to show or prove. Now we needed to show a calculation. Okay, that's all right. Another one may just choose to mark the left-hand side and the right-hand side of that equation and then milk out the rest. The first mark going for that technique, I don't know. It doesn't matter. But I think we have our 5 marks and we are happy. Alright guys, I hope you've enjoyed this lesson, and give it a thumbs up. Please don't just watch and let go. I cannot have views that are not matched by the likes, okay? You can't view without a like. Even if you didn't like it, just like it, okay? So that the other people who may actually like it can be helped by you. So sometimes, even if you don't like something, but for the fact that it can help somebody else, I would rather you just do so, because this follows the algorithm. With the more likes, it becomes more visible to others, and so if it reaches them, they might just benefit from the narrative, if at all possible. Otherwise, guys, it's not a big deal. Do whatever you will. It's your choice, honestly speaking. I actually don't really care. If you are not lucky to see this and perhaps it will help you, well, tough luck. If you don't like it, well, it's okay. Move on. But for my students, obviously, guys, you have the duty to like these so that even your friends can win. Don't gatekeep. I know some of you want to defeat that bright student in your class who probably has been showing off for all these years, and now you finally perhaps have gotten some help through this, and now you want to show your might. It's okay. If you want to do that, do it. But remember, the real winners don't gatekeep anything, but you just beat people on the level ground. You give them what they have, what you have, so that there's no issue of saying you've had an advantage over them. You just defeat them with the same resources as yourself, or even far less for yourself, and they have more on the other end. But again, guys, remember, the competition must never be toxic. It must be a healthy competition. If you are to compete with anybody for anything, okay, it must be healthy, so that if you lose, you don't become bitter. Anyway, guys, that's it. I will see you guys in the week when we resume our classes on Monday. Don't be late.